Okay, welcome back, Algebra 2 students. So, in this lesson, we're going to go over section 2.2, solving linear systems using elimination. So, this set of problems is pretty similar to the last section that we looked at, except now it's going to be wise to use elimination all the way through to solve our systems. The reason being is that well, notice that all three of these equations, none of them are isolated for any particular variable, and all three of them have three variables each. So even if we find a variable that's reasonably nice to isolate, we're still going to be juggling around a lot of stuff when we're trying to pull off our substitution. So in this case, we're actually just going to go with elimination all the way through. So the first step is going to be that we have to choose a variable to eliminate. So when we're choosing a variable to eliminate, we want to think of what's going to be the smallest numbers that we need to multiply to multiply each equation by to get variables to cancel. Notice that we implicitly have negative 3, 1. We have implicitly a 1 for a coefficient here on the second equation, and a negative 3 and a negative 1 for the coefficients on the first and third equations. So that means that if we want to get any variables to eliminate, well, first of all, this is implicitly a negative 1 on the coefficient for x. If we were to just add equations 2 and 3 together, we would get the x's to cancel. If we were to look at maybe entertaining canceling y, we could do that. And none of these are inherently wrong to cancel. It's just we want to try to make this as easy as possible on ourselves. This is a coefficient of negative 1. We have a 4 and a coefficient of negative 3. So I got to multiply, say, this equation by either negative 3 or positive 4 to get the y's to cancel. And we're going to need to eliminate twice in order to pull off an elimination. So we could do y. That's an option. X is still looking like the better option for right now. And then for z, we have negative 3. We have a positive 1. And we have a positive 4. So for z, okay, that's better that option than, I guess, y. Well, not really, because, I mean, we still have a negative 1y here. So none of these are necessarily bad to try to cancel. It's just, I think x is probably going to be the best way to go since we already have a positive 1x and a negative 1x here. Let's see, and it looks like my camera's a little bit out of focus. I'm going to try to focus that quick. Okay, that looks a little bit better. All right. So, anyways, we're going to roll with eliminating x. And again, you could do any of the variables. It's really not going to matter in the end, but making our work easier on ourselves is usually the way to go. So, if I just start with equations 1 and 2, if I just rewrite those, I have x plus 4y plus z is equal to negative 19. And we have negative x minus 3y plus 4z is equal to 0. If I add these two equations together, the x's will cancel, and we have 4y minus 3y, which is just y. Then we have z plus 4z, which is 5z. And then we have negative 19 plus 0, which is still just negative 19. And so we're still going to have this objective of reducing our three equations with three variables into two equations with two variables. And by eliminating x, we now have an equation in just the variables y and z. So in this case, we used equations, we used equations 2 and 3 to make this elimination. Now we need to eliminate x again, but we need to use a different combination of equations. We can use either 1 and 2 or 1 and 3, or really, I think that's about it. So let's maybe multiply, say, the middle equation, equation 2, by 3. That way we can eliminate that with a negative 3x, and we'll have a positive 3x here. So if I start off with my top equation of negative 3x minus y minus 3 is z is equal to 13. And my middle equation is x plus 4y plus z is equal to negative 19. What I'm going to want to do to eliminate x is I want to multiply this bottom equation by 3, and I'll keep the top one the same by multiplying it by 1. But that's going to give us negative 3x minus y minus 3z is equal to 13. And the bottom equation by 3 is going to be 3x plus 12y plus 3z is equal to negative 57. Now this is nice because not only is x going to eliminate, but so is z. And we're actually just going to be left with 11y is equal to, it's going to be negative 44. So since we have 11y is equal to negative 44, we can actually just go ahead and divide by 11, and we have y is equal to negative 4. So this is nice. Normally we would usually get an equation with, in this case, y and z, and then we would have to use this equation and whatever equation we got over here, and probably use elimination again to try to isolate a variable. But in this case, we just had a very nice elimination that y is equal to negative 4. So since we know that y is equal to negative 4, we can substitute that back into this equation over here, and that's going to give us negative 4 plus 5z is equal to negative 19. And now what we can do is we can add 4 to both sides. We have 5z is equal to negative 15, and then dividing by 5, z is equal to negative 3. Now that we know that z is equal to negative 3, we can substitute that into really any of these equations. I'll go with equation 2, just because we already have a positive 1x there, but then plus 4 times y, which was negative 4, and then plus z, which was negative 3, is equal to negative 19. And 4 times negative 4 is just going to be negative 16. And then plus negative 3 is really just going to be minus 3. And since we have negative 16 minus 3, that's really negative 19. We have x minus 19 is equal to negative 19, which means if we add 19 to both sides, we get x is equal to 0. So x is equal to 0, and we want to write our final answer as a coordinate. We're going to write x, comma y, comma z is equal to 0, comma negative 4, comma negative 3. And so we have our final answer of this coordinate 0, negative 4, negative 3. All right, let's try the next one. We're going to go on to number 3. Again, as usual, the odds are going to be examples and the evens are going to be your homework. So for number 3, we want to choose a variable to eliminate. Pretty reasonable elimination just right off the bat is notice that we have an r and we have a negative r here. So if we just take equations 1 and 2, we can have r plus 3s plus t is equal to 9. And then the second equation, negative r minus s plus t is equal to negative 3. If we take those, we add our two equations together to eliminate r. It's going to give us 2s plus 2t is equal to 6. Okay, and by the way, anytime we can, we should reduce our equations if we can. Like, notice that all of these numbers are divisible by 2. We can really just write this as like, s plus t is equal to 3. If we can work with smaller numbers when we can, we should. It'll make things a little bit easier for us. But this was using equations 1 and 2. Now we have to use a different pair of equations. And what if we use equations, say, 2 and 3? Because all we have to do to eliminate r again is multiply this the middle equation by 4. So if we take negative r minus s plus t is equal to negative 3, and then the bottom equation, 4r plus 4s plus t is equal to 17, we can get r to eliminate, again, by multiplying this one by 4. We'll keep the bottom one the same, and that's going to give us negative 4r minus 4s plus 4t is equal to negative 12. The bottom one the same. We're going to have 4r plus 4s plus t is equal to 17. And when we add these together, r's cancel, and hey, look, that's kind of nice. S is canceled too. Again, that's not always going to happen, but it does leave us with 5t is equal to 5, which means that t is equal to 1. And now that we know that t is equal to 1, we can go back to this other equation where we only have s and t, and we can say that s plus 1 is equal to 3. In other words, s is equal to 2. So now that we know that t is equal to 1, s is equal to 2, we can go back to any of our equations up here with r and find r. I'm going to roll with equation 1 just because we have a positive 1r already. So that means that r plus 3 times whatever s is, which is 2, plus whatever t is, which is 1, it's going to be equal to 9. That means we have r plus 6 plus 1 is equal to 9, which means that r plus 7 is equal to 9, which means that r, subtracting 7 from both sides, r is equal to 2. And so now that we know what each of our variables is, our final answer, again, keeping these in alphabetical order, r, s, t, is going to be 2, 2, 1. And there we go. So that's our final answer for number 3. Let's look at the next one. For the next problem, again, let's try to find a variable to eliminate that's going to be most convenient. Hey, look at this. If we have y, we have a positive y, and a negative y. I don't even have to multiply by anything to get y's to cancel here. I can use equations, say 1 and 3, and then 2 and 3, and we won't even have to multiply by anything to get variables to eliminate. We can, of course, roll with x or z, but that's going to require a little bit more work because we have to multiply by some numbers to get our variables to eliminate. So less work is usually better. So if we use equations 1 and 3, that means we have negative 3x plus y minus 4z is equal to negative 8. And then we have x minus y plus 2z is equal to 6. These, we don't even have to multiply by anything. The y's will cancel. And we have negative 2x minus 2z is equal to negative 2. So, and just like last time, I mean, if we can work with smaller numbers, we should. If we can divide all of these by, say, 2, we'll have negative x minus z is equal to negative 1. And you could write it as, if you divided by negative 2 as x plus z is equal to 1. Either one works. It doesn't really matter much. Let's just see what the other equation comes out to. So again, that was using 1 and 3 for our two equations. Let's use 2 and 3 for the next pair of equations. If we do that, we have 2x plus y plus z is equal to negative 3. And then we have x minus y plus 2z is equal to 6. Adding these two together, the y's cancel. We have 3x plus 3z is equal to positive 3. And hey, look, if I, again, reducing these, if we can, all of these numbers are divisible by 3. I can write this as x plus z is equal to 1. And look at that. We have this equation here, and we have this equation here. We could use that one too. But if you remember from the last video, because remember this one is also equivalent, if we ever ended up with the same equation twice, we could say this is infinitely many solutions, or say we didn't recognize that we could divide by negative 2 over here, and we just rolled with this equation. Even if we had this one and this one, we would have negative x minus z is equal to negative 1 for this equation, and then x plus z is equal to positive 1. If we add those together, all of our variables cancel and our constants cancel too. We end up with that 0 is equal to 0 condition, which means it's true. And that's, again, how we justify that we have infinitely many solutions. So that is our final answer for this one. 6 is homework for you. Let's look at number 7 now. So for number 7, let's see. Well, let's see. Easy variables to eliminate. I guess we can roll with x. Or better yet, let's roll with z. Because look, there's not even a z in the third equation. If we just eliminate z between equations 1 and 2, the second equation with just two variables is already done for us. So let's use equations 1 and 2, where we have x minus 2y minus z is equal to 4, negative x minus 4y minus 3z is equal to negative 15. And if we try to eliminate z, what we can do is we can multiply the top equation by negative 3. And that's going to give us negative 3x plus 6y plus 3z is equal to negative 12. And if we keep the bottom equation the same by multiplying it by 1, we have negative x minus 4y minus 3z is equal to negative 15. Then when we add these two together, the z's cancel. We have negative 4x plus 2y, and that's equal to negative 27. Now check that out. We have negative 4x plus 2y, 4x minus 2y. Those are just the same thing with opposite signs. So if I take the third equation, 4x minus 2y is equal to 14, and I add that with the other equation that we just got from eliminating z in equations 1 and 2. Let's see. So negative 27. There we go. And now, if we add these two equations together, we get another one of our special solutions because the variables on the left cancel and we get 0. But on the right, we have 14 minus 27, which is going to be negative 13. And because this is false, we can conclude this is no solution. And there we go. So that concludes number 7. Let's look at number 9. So number 9, again, we try to hunt for easy variables to eliminate. If we look at y here, notice that if I multiply this by 2, I'll get a negative 4. Then I can add this with equation, I can take equation 1 and 2 and I can add them together and the y's will cancel. And then I could add equations 1 and 3 together and the y's will cancel. So, and you could multiply, say, the top one by 4 and then the bottom one by 4 and get the x's to cancel. Or you could multiply this one, the middle one by 4 and multiply it by negative 3 to get the z's to cancel. But the less multiplication, the better. So let's just eliminate y. I'm going to take equations 1 and 2 and we're going to eliminate y. If we do that, I'll write the two equations down real quick just so we're really neat about this, make sure that we have everything organized properly. So we have our two equations, and we want to eliminate y, so we're going to multiply the top one by 2, so that way this is a negative 4, and it cancels out with a positive 4. So multiplying by 2, we have negative 2x minus 4y plus 8z is equal to negative 8. And if we keep the bottom equation the same, this is going to be a 4x plus 4y minus z is equal to 5. Now that the y's will cancel, when we add these together, we have negative 2x plus 4x, and that's going to be 2x, and then we have negative 8z plus z, minus z. It's going to be plus 7z, and that's equal to negative 3. Okay. So that was using equations 1 and 2. Now let's use equations 1 and 3. Same thing, we're going to multiply the top one by 2 just to make this a negative 4 and cancel with the positive 4. So using, 1 and 3. So that means we have, again, negative, and I mean, I'm multiplying it by 2. I'm just going to write down this equation that we got over here. No need to multiply everything, write this whole thing again. So it's just minus 2x minus 4y plus 8z, and then is equal to negative 8. And now if I take equation 3, negative x plus 4y minus 3z is equal to negative 3, and I add these together, our y's are going to cancel. We have negative 3x plus 5z is equal to negative 11. Okay, let's see, that x was a little bit sloppy, so I'm going to fix that real quick. Okay, so we have this. All right, let's see what we get. So if I take these two equations, I'm going to take the 2x plus 7z is equal to negative 3, and then negative 3x plus 5z is equal to negative 11. Okay, we got to eliminate a variable. Let's see. We want to minimize the numbers, the magnitude of the numbers, or how big the numbers are that we get when we, multiply these out. I think eliminating x is probably going to be the better option here, because I can multiply this one by 3, and I can multiply this one by 2. And that means that, 2 times 3 is going to be 6, and then negative 3 times 2 is going to be negative 6. We'll have 6x and negative 6x. The x's will cancel. Now, of course, we can eliminate z as well, but that's going to require us multiplying by like a 5 up here and a negative 7 down here. And the numbers are going to get a little bit bigger than we're not necessarily like uncomfortable with, but it's not going to be as... we're more prone to making a mistake if we're doing this all in our heads. So smaller numbers for the win here. Let's multiply the top one by 3. That's going to give us 6x plus 21z is equal to negative 9. And then the bottom one by 2 is going to be negative 6x plus 10z is equal to negative 22. Now, combining all of this together, we have the x's cancel. Let's see, we get 21 plus 10, that's going to be 31z. And now we have negative 9 minus 22. And that gives us negative 31. So, dividing by 31 on both sides, z is going to be equal to negative 1. And now that we know that z is equal to negative 1, we can substitute that into either one of these two equations with just x and z. Sure, let's roll with this one over here. That means we have 2x plus 7 times negative 1 is equal to negative 3. That gives us 2x minus 7 is equal to negative 3. Adding the 7 to both sides, we get 2x is equal to positive 4, which means that x is equal to 2. So now that we know that x is equal to 2, we can find y now. So we can roll with any of these equations. I don't know, middle one. If we roll with the middle one, that means we have 4 times x, so we have 4 times 2 plus 4y minus negative 1 is equal to 5. That gives us 8 plus 4y plus 1 is equal to 5. Combining 8 and 1, that gives us 4y plus 9 is equal to 5. Subtracting 9, we get 4y is equal to negative 4. And then dividing by 4, we get y is equal to negative 1. So, combining all this information together into one answer, we're going to write this as a coordinate as x comma y comma z is equal to 2, and then negative 1, negative 1. And so, this is our final answer for number 9. All right, moving on to number 11. Number 11, we're going to pick a variable to try to eliminate. Let's see. We can. Let's try B this time. C might be a little bit easier just because we have to multiply by, say, -2, but let's try one that's not so easy. Um, just to, flex our math muscles here. So let's eliminate B. Let's start with equations 1 and 2. We have -2a plus 4b minus 4c is equal to -14. And then we have 3a minus b minus 4c is equal to 1. If we want to eliminate b, let's multiply the bottom one by -4. We'll keep the top one the same. That means we have -2a plus 4b minus 4c is equal to -14. And then if we multiply the bottom one by -4, we have -12a. We don't want to multiply by -4. Sorry about that. Because if we multiply by -4, that's going to make this also a positive 4b, and that won't cancel. So back up for a second. Let's do 3a times 4. That gives us positive 12a. And then -b times 4 is going to be -4b. And then we have -16c is equal to 4. If we add these together, we're going to get 10a, the b's will cancel, minus 20c is equal to -10. And of course, we want to reduce equations as much as we can. Notice that all of these numbers are divisible by 10. So really, we're just working with a minus 2c is equal to -1. Now let's roll with eliminate. We want to eliminate b one more time. I was using equations 1 and 2. Maybe we can use equations 1 and 3. We can multiply the bottom one by -2, and let's see what happens. So 1 and 3, we have -2a plus 4b minus 4c is equal to -14. And if I take the bottom equation, -a plus 2b minus 2c is equal to -7. If we multiply the bottom equation by -2, we'll have 4b times -4b here, and then positive 4b. Top equation is -2a plus 4b minus 4c is equal to -14. But the bottom equation, multiplying everything by -2, is going to be a positive 2a minus 4b plus 4c is equal to positive 14. Whoa, look at that. So all of our variables cancel on the left. And on the on the right, we also have cancellation of 0 is equal to 0. So since we have a 0 is equal to 0, that tells us that this is true, and that means that we have infinitely many solutions. Now, a quick note about this. It is entirely possible to get 0 is equal to 0 and this still be no solution. And that really depends on what happened with this other pair of equations. So if you're doing elimination and you still get, on your first elimination you get 0 is equal to 0, you can't quite conclude that this is going to be infinitely many solutions. You have to check one more elimination at least to make sure that you still get some other equation that's not 0 is equal to 1 or 0 is equal to another number. Now your assignment won't have anything like that on there, but this is just for like an FYI that make sure that you get, if you have 0 is equal to 0, that you also have another equation with another elimination. So that's just something to look out for. But again, I didn't make that something you have to be mindful of on this assignment. This is just in case you decide to explore more advanced linear algebra later in your high school or college career. So, not necessarily always the case with this. But let's look at number 13. So for number 13, let's choose a variable to eliminate. Let's see, I guess y is probably the easiest. I can multiply say the top by -3 and keep the bottom one the same, or not the bottom, the middle one. So using equations 1 and 2, we have -2x minus y plus z is equal to 1, and then -4x minus 3y minus 2z is equal to -6. And we want to eliminate y, so we're going to multiply this one by -3 to make -1 times -3 to make a +3. So we'll have 6x plus 3y minus 3z is equal to -3. And keeping the bottom one the same, we have -4x minus 3y minus 2z is equal to -6. When we add these two together, the x's are going to cancel. We have 6x minus 4x, which is really just 2x, and then -3z minus 2z is minus 5z, and then -3 minus 6 is going to be -9. So we have our first elimination here. Let's try to eliminate y one more time. Let's use, say, equations 1 and 3. We can just multiply 1 by -1, and then the y's will eliminate. So using 1 and 3, let's see, I'll just write out the full equations again one more time, so we see that how we're changing the equations to make them eliminate. So if I multiply, say, the top one by -1, you can do the other one too, but if we multiply the top one by -1, that's going to give us 2x plus y minus z is equal to -1. Keeping the bottom one the same, we have 3x minus y minus 3z is equal to -13. If we add these two together, we're going to get 5x, the y's cancel, minus 4z is equal to -14. Okay, so using these two equations that we have, this one and this one, now we got to eliminate another variable. And so we have, just rewriting those, 2x minus 5z is equal to -9. And then 5x minus 4z is equal to -14. So we want to eliminate a variable. Easiest variable to eliminate so that we don't multiply by bigger numbers than we need to would probably be x, because we can multiply the top one by 5 and the bottom one by -2. So if we multiply this one by 5 and this one by -2, we're going to get 10x minus 25z is equal to -45. For the bottom one, we'll get -10x plus 8z is equal to 28. Adding them together, the x's will cancel. We have -25z plus 8. That's going to be -17z. And -45 plus 28 is thankfully -17. I was getting a little bit worried about that with some of these numbers, but that means that z is equal to 1. So since z is equal to 1, we can now find x, and we can use any of the equations. I don't know, this one, sure. So that means we have 5x minus 4 times 1, I'll just write minus 4, is equal to -14. And so we have 5x, adding the 4 to both sides is going to be a -10, and dividing by 5x is going to be equal to -2. And now we can find y. We can pick any equation we want. Sure, I'll do the top one. If we do the top one, we have -2 times x, which is -2, minus y plus z, which is just 1, is equal to 1. That means that we have 4 minus y plus 1 is equal to 1. 4 plus 1 is 5, so we have really negative y plus 5 is equal to 1. Subtracting 5, we have negative y is equal to negative 4. And then remember, if you have a negative variable and a negative number, and you want to get this variable to be positive, just flip the signs on both sides. You can also think of it as like dividing or multiplying by negative 1, but sometimes it's just easier to remember that, oh, if I have a negative variable, just flip the signs on both sides, and that will give me my answer. So now that we have this, we can write all of our information here as a coordinate of x, comma y, comma z is equal to negative 2, 4, and 1. All right. So last one, we just have number 15. So for number 15, let's see what we have. Let's choose a variable to eliminate. I think a pretty prime candidate here is probably z, because we can negate one of the equations 1 or 2, and then we can multiply one of them by 4 to eliminate z with equation 3. However, notice that even this bottom equation here, notice all of these are divisible by 4. If we take this bottom equation, we have 4, oops, sorry, not 4x. If we divide everything by 4, we're just going to have x plus y minus z is equal to 4. And, well, look at the middle equation. You have negative x minus y plus z is equal to 10. Huh. If we add those two together, 0 is equal to 14. So, unlike the infinitely many solutions, we don't even need to check if we get another equation from another elimination. As soon as we get a false statement such as 0 is equal to 14, that's no solution. There's nothing else that we have to do. So this one is actually really quick. So anyways, that concludes all of our examples for section 2.2. So I will see you guys in the next one.